All right, so in a regular semester, I usually start with motion because that is the classical mechanics. That is the first kind of sciences. It's in physics. This is where everything gets started, that studying the motion of things. So Aristotle and then the Galileo. So those people try to move things around and see like how it's behaved. Maybe you have heard about the stories about Galileo. So he used to throw things out and roll things along the ramps. So he used to throw metal balls from the tower, Pisa Tower. So he used to go up into the tower and throw or leave left, like just drop metal balls. So he used to do that experiment. These days, we don't need to do that because everything got found out, like why it is moving, how it is moving, why it is moving downward rather than going into the air, like high in the sky, right? Even though you throw something up, it's go up, but it's coming back. So we all know like how to explain that motion. So that is what we're going to learn in this topic. So again, it is the classical mechanics where we're going to learn about motion of things. And it is a very important topic, and it's a good topic to learn because in many places we are using these motion ideas. Like you're driving a car and the highway patrols are there, right? So they're catching for high speeds. It's physics, and they're using speedometers to check those. And you're using your vehicle speedometer. That's another example. So there's so many applications in real life regarding this classical mechanics. And then if you go beyond the earth and if you go to the space, then all these planets are moving, right? So they're not stationary. Even the sun is moving around itself, and also it's moving. It's keep moving. All these galaxies are keep moving. So now, by now, the scientists are able to explain all this motion, including black holes. So recently, yesterday actually, on yesterday Astronomy News, I noticed that using a telescope, scientists has observed a black hole is taking a star in. It's just absorbing a star. So it's kind of eating, right? So they're digesting a star into a black hole. So yesterday they observed that with a telescope. All right, so getting to the topic. Where's my slide here? All the slides are available on Canvas. Introduction. Can you see a PowerPoint slide? I believe yes, right?
Yes.
All right, so science in general and physics in particular deals with simple systems. So we're going to analyze this simple system. So the most advanced stuff will be the simple harmonic motion. Like if you take an object, let's say something hanging around like a pendulum. So you're going to, let's say, if you were in the class, I have solved so many demonstration materials, but here I don't. So here's kind of something hanging from a rope and it's just oscillating, right? So that's the most advanced that we will go. But beyond that, we are trying to describe the motion of simple things. So I believe you know who is in the picture. So to see well, we must stand on the shoulders of giants, because we are not going to do everything by ourselves. We're going to see like what they have found and is it acceptable. So we're going to test out with the equipments that we have, and then we believe on giants and we think, oh, okay, it's makes sense. So far, Newton's laws never broke up. So it's still there. Newton's law agree with any motion that we are observing. So we are stick with those laws still to describe the motions. So I think by now you understand physics is not just math, right? But when you're talking about motions, we will include some mathematics in there to calculate the distances, displacements, and the speeds and velocities, accelerations. It is just divisions, but we are not going to go in, bring a lot of mathematics in there. However, it is really nice to understand the fundamental of physics conceptually. So we're going to use diagrams and explain it using words, or maybe we can draw graphs. So I know like most of you are taking the lab class, so you notice like we are drawing graphs and do some calculations, and from there we compare with the theory, and then from the graph we can get a lot of calculations out, like finding out unknown quantities. And then also we draw pictures to understand things better. So there are so many ways that we can describe things. So we doesn't need to be stick with only words. But if you're taking a history class, you need words, and you need to by heart everything and write it in nice paragraphs, right? In physics, we don't need to do that. Even in chemistry, we don't need to do that. We can draw diagrams and explain things. All right, so here's a cool video. I don't know whether you can see it, but I will send you the link to that. Let's see. So if you have good internet service, maybe you can see the videos when I'm playing from here. But it's a very cool one. Yeah, motorcycle is a motorized vehicle, right? But the bicycle is going from gravity and the power that we give him by our foot, by paddling. So he changed his posture to make himself horizontal. So basically his mass distribution is different than a regular bicyclist. So the speed gain is maximized by changing the distribution of mass. But that motorcycle person, he cannot gain that speed by changing his posture because it's a motorized vehicle, right? There will be a little effect from the gravity if he's coming down in the hill, but it is a motorized thing. So it's driven by the motor, but the bicycle is going by the gravity. So by changing the mass distribution, you can gain speed or low down. Okay. So I don't know. I believe if you, after this section, you should be able to explain this motion and apply into yourself. Do we have any cyclist here, like who's going to competitions? I don't know. I ride bicycle, but I never go to any competitions. All right. So things are moving. We know that by taking this class, we need to kind of like we're trying to quantify this movement and try to explain it a little bit in scientific way. So in order to do that, we need to define the units. So there are fundamental units. It's not only physics, like in any subject, we can use these units. So fundamental units, that's our base units. So we measure the length in meters, and the unit is m. The symbol for unit meter is lowercase m. Then the mass measured in kilograms, symbol is lowercase k and lowercase g. Time measured in seconds. Electric current, it's ampere. Then the temperature. So we use Fahrenheit, right? But the fundamental metric unit is Kelvin. It's uppercase K. Then the luminous intensity, candela, it's CD. And amount of substances, moles. So these are the 1, 2, 3, 4, 5, 6, 7 fundamental units, base units. So by using these 7 units, we can define unit for any other quantity. I mean, anything that, let's say we need to define the speeds, then we can use meters and the time, second for time, and we can define or a new unit for the quantity. So here, like even though I mentioned that the length is measured in meters, in our general use, we use miles to measure distances, right? So there are various systems of units. So in SI units, we use meters to measure length, kilograms for mass, and second to measure time. But when we go to the CGS system, centimeters, gram, and second will be used to measure length, mass, and time. Then in the US customary values, we are using miles to measure length and pounds to measure mass and hours to measure the time. Why? That's depend on the user. So we live in a larger country. So if we use meters, we need a big number to measure the distances. But when you're using miles, it's a small numbers, so we can use it like easily. But it is okay. We can use meters to measure distance, right? Anyway, so the SI, the metric unit is meters to measure length, and mass measured in kilograms, and time measured in seconds. So when we want to have the SI units, we cannot use anything other than this. So miles per hour is not a SI unit. It is our US customary unit to measure the speed. All right, so what does it mean by one-dimensional motion? Maybe you have heard about like one dimension, two dimensions, and the three dimensions. Nowadays, if you go to the movie theaters, they talk about four-dimensional, right? So basically, what does it mean by one-dimensional motion? So if you see this animation here, this car is moving horizontally, let's say. So it's moving horizontally. So it is moving in a one direction, right? So it is a one-dimensional motion. And in mathematics and physics, we call the horizontal direction most of the time as the x direction. X stand for the horizontal direction, but we can rotate this coordinate system. However, in most places, we say the horizontal direction is the x direction. Then if the car is moving like vertically upward, that's another dimension, right? So it is we call this as the y direction. uh, if the car is moving only in the vertical direction, it is a one-dimensional in vertically, right? So it is a one-dimensional motion. Now, how about it's moved diagonally? Is it one-dimensional? Now here, if you look at the XY coordinate, then we do see like it's moving in horizontally. At the same time, it moves vertically upward. So you might say like it's two-dimensional because it's moving both in X and Y direction. I agree. So that is how you define your coordinate system. If you say, okay, horizontal direction is my X direction and the vertical direction is my Y direction, then this car that moving diagonally is moving in two dimension. But how about if I define a new direction? That direction, this is whatever the diagonal direction, a new coordinate, it is a one direction, right? So we can define that to be a one-dimensional motion. So again, it is depend on the user who's going to define these directions or dimensions, right? So here x, that is one dimension, y is another dimension, and whatever the middle diagonal direction is another direction. So these are independently, they are one dimensional, but if you combine these x, y, and maybe let's say this is the z direction, so those are the three dimensions. So what we mean by one-dimensional motion means it's moving in particularly in a one particular direction. All right. So negative numbers and the positive numbers in the number line can be used to define these directions. So here, this is a number line. So at the center we see 0, and then from to the right side we have the positive numbers, and to the other side it's negative numbers. So so basically, in physics, what we're going to do is we define the 0 position, and then the positive direction is indicated by an arrow. So we are using arrows to represent the direction of motion. And in many places, in many books, and in our class, we're going to define our positive direction by using an arrow. So arrow is pointing in the positive direction. See like this one, see here, we draw it into this direction. This is the arrow, so that is the positive direction. It's increasing in the positive way. Now at the same time we can flip it, so it doesn't matter whether we are writing numbers on the left or right. So here I wrote it 1 2 3 4 on the left side. It doesn't matter, we can flip it over and say, oh, this way is positive. Again, it's depend on how you're going to define the direction. Okay. Now, what does it mean by changing in a quantity, right? So the change in a quantity equals its final value minus the initial value. So for example, let's say I'm moving myself, I'm driving my car. I started from 0 miles per hour, then I gain the speed into, let's say, 75 miles per hour. So that's a change in speed from 0 to 75 miles per hour. So the final value is 75 miles per hour, and the initial value is 0 miles per hour. So in particular time, I change my speed values, right? So we call this as the change in speed. Likewise, for anything, we can calculate the change in quantity by calculating the difference between the final value and the initial value. So let's think about a Q quantity. So, like in, we can define any unit, any quantity here, but generally, let's say there's a quantity called Q, then let's say the initial value is represented by QI. So in textbooks, we are using these symbols. So Q means whatever the quantity, and I means the initial value of that quantity. So this Q can be anything like distance, speed, acceleration, anything, okay? Then the final value is represented by QF. F stand for final. So when you're calculating the differences in quantity, then we use this delta sign to use indicate that there's a change in this Q quantity. So change is represented by delta, whatever the quantity Q. So change in quantity Q is equal to whatever the final value of the Q value minus the initial value of those Q quantity. Okay, so these are the symbols that we're going to use. Then the rate of change of something. So rate of change means how much it's taking over the time. So if you take this amount, the change of this Q divided by the time it's taken, we can calculate the rate of change of the other quantity. So basically we take the final value of the quantity minus the initial value of the quantity, divide by the time it's taken. So it's T final minus T initial. See how I define it? It's TF, that stand for time final. And the TI, that's the time initial. So basically you take the final time minus the initial time. That means the change in the time, right? So it's delta T. So we are going to use this type of equations in next topics. Okay, so we need to define, in order to describe the motion of an object, we need to define the distance, then displacement, speed, and velocity. So for all of us, distance is familiar quantity and speed also somewhat familiar, right? Velocity, sometimes we do use that. So most of the quantities that we are hearing here is very familiar to us. But let's see what are the definition of these quantities. This time I created short PowerPoint slides, so it's easy for me to upload onto the canvas. Right, so let's define the distance, then displacement, and then speed, and then the velocity. So that's the plan. So let's look at what is the distance mean. So distance is the length of the actual path taken by an object. So we basically, that is the path length. So as in this as animation, let's think about an object that's located at position A, and let's say it's moving to position B. So we don't care what path it takes. So according to this animation, whatever the object, let's say a car, the car started from this position and then it went along this path and went to the part B. So distance means the length of the actual path taken. So it's went from A to B in this path, right? So we measure the distance along this path. So starting from here, you go along this way, let's say it is 20 meters. So the distance from A to B is 20 meters, no doubt, right? So if you're traveling somewhere, you measure the distance by the path length. And the symbol we are going to use here for distance is S, and the unit is meters. That is the SI unit, right? Here we don't care about the direction. Here this car moved upward, and here it's just kind of horizontal and going downward, horizontal, then upward, right? So the direction is varying, but we don't care about the direction when we are measuring distance. We measure the total path length of this motion. So basically, when you're calculating the distance or measuring the distance, we just only care about the magnitude. That's just a number with a unit. So here, basically, it is 20 meters. All right, now the displacement. What is displacement? Displacement is the straight line separation of 2 points in a specified direction. Now here, we are bringing the idea of direction. So directed distance, let's say, right? So here, same motion. So an object is moving from A to B, and we know what is the distance is. Now here, this is the motion. The green color lines represent the real motion. Now, if you join A and B using a direct line here, straight line. So now let's measure the distance from A to B along this black line. So that is the displacement. Now, displacement is going from A to B. That's true. But the path is like, you need to define a direction here. We don't have any directions like south, east, west here labeled, but you can see the horizontal line here, right? So if you draw an horizontal line, let's say that is the east direction. I really don't know, but I can define my direction, right? So here I draw a line like horizontal line, and let's say that is the east direction. Then from there, I measure the angle to this displacement. So from this black line, that is the displacement. So I measure this angle. Let's say this is 20 degrees. So if you measure it using a protractor, let's say this is 20 degrees, and the distance from A to B, is 20 meters as we learned earlier. But if you measure the length from A to B along this black line, it is 12 meters. So here we say the displacement of this vehicle is 12 meters in 20 degrees to the horizontal or to the east. From east, it's 20 degrees. Or you can say from the horizontal, positive horizontal direction, it's 20 degrees. And the value is 12 meters. So we say the displacement is 12 meters in 20 degrees from east. And displacement is a vector quantity. What is a vector? Vector means you need to include the direction into the quantity. So it is not just a number, but you need to say what direction it is. So for example, here, the change in the displacement is whatever the distance from A to B in the straight line, 12 meters, and the angle is 20 degrees. So displacement is basically change in position. So this position of the object moved from A to B, and the direct distance is 12 meters in this example. Again, SI units to measure distances is meters. So unit will be meter. But here, this value, the direction value is really important. It can be anything, like you can use the degrees to define the direction, or you can use east, west, or positive direction or negative direction. So it's really depend on the user. So we can define our directions. Now, displacement in one dimensions. So let's put some numbers in here. So let's say the object is moved in that particular direction, but this is the path it taken. So the red color line represents the path of the object. So it's moved from this position. That is the first position. And it's moved to this position over here. That's the final position. And here the dash line represents the horizontal direction. So in physics, we say this is the X direction. Now that blue color line represents the displacement because it's moved from this location to this location. If we don't care about the path it's moved, this is going to be the displacement, right? Now let's define our position. So let's say this is the starting position. Let's say that is X equals 0 in a number line. Let's say this is the 0 position. That's how we're going to define it. And this is the start point. So we say XI because it is moving in X direction, right? So this is the initial position of the whatever the object that moving, and then it stopped over here. So that is the final position. So from there we can calculate the displacement, that is the change in position. So what we basically do is we take the final position minus the initial position. SI unit should be meters. Okay, so that's the displacement. Now let's put numbers. So let's say initial position is 0 over here. Sorry, that's the coordinate 0 position, reference 0. And let's say this is 20 meters. That's the position it gets start moving. And this is the end position, 100 meters away. So the object moved that way. We really don't care about the path it taken, but it's finally it's moved from here to here, right? So initial position and the final position. So here we can calculate the displacement. That's the direction it moved. So let's say that is the positive direction. So the delta X, that's the change in position in X direction, will be final position minus the initial position. So basically it will be 100 minus 20, right? So 100 minus 20, it is 80 meters, and the displacement is positive because positive X direction. So it is a positive 80 meters. Let's say it's reversing. So it's going backward. It's moving from the final position to the initial position. Then things are changing because this is how I'm going to define my positions, right? So it's started from somewhere here. That's going to be positive 100 meters, and it's moved back to the 20 meter. So that's going to be the final position in the new case, in the second case, right? So now the displacement is X final minus X initial. Now X final is 20 meters because it's went backward to 20 meters, and the initial position was 100 meters. So 20 minus 100, it is negative 80 meters. So the displacement is in the negative direction by 80 meters. Okay, so the displacement in the first case, it's moved towards positive direction. So the displacement was positive 80 meters. Now in the second case, it's moved in the backward direction. So the displacement is minus 80 meters. Okay, so in this example, positive answers indicate the motion is in positive x direction. Negative answers indicates that the motion in the negative directions. So displacement has both a magnitude and a direction. So displacement is considered to be a vector quantity. Vectors means it's have a value, the magnitude value and a direction. For example, here it's 80 is the magnitude value and the direction is positive direction, positive x direction. It can be east, west, the way that you defining your directions. Okay, so it's okay to use positive and negative, but it need to be indicated in the picture. All right, so let's think about this example. So let's say you are throwing a ball straight up and then catch it at the same point that you released it. What is the distance it traveled and what is the displacement it traveled? Okay, I don't have a ball. Do I have a ball here? No, I don't. So let's say I'm using something. I really don't have anything here. What do I have here? I have a clip, okay? I wish I have a ball here. I think my kids taken all the balls that I had on the table. Anyway, so I have this object, so I'm going to throw it up and I'm going to catch it at the same point. So what do you think? What is the distance it traveled and what is the displacement? So remember the way that we define the distance, that is the total path it taken, right? And the displacement is the change in the position. So the distance traveled will be twice as the height it traveled. So let's say it's moved from this position from the table to some height. So that is the path it taken to up. So let's say this is the height h and it's go backward again to the same position. So 1 time height and the 2 times height, right? So it's twice as the height, that is the distance it traveled, and the displacement, it came back to the same position, right? So start position is on the table and the end position is on the table. So there's no displacement because it's at the same point. So the displacement will be 0. It's tricky, isn't it? But these quantities are really important when we are talking about motions, like especially in rocket science, like let's say you are launching something, then we are doing this calculation using these vectors. It's a really important thing to do. So something to remember. So the displacement is not as the same as the distance. So there are two different things. Distance means the total path it traveled. Displacement means how much it moved from the first position to the second position. Okay, I believe it makes sense. Let's look at your chat. Yeah, that's correct, Gofran. So let's see what is speed and velocity. What to be? I'm going to spend a little bit more time on these slides and then we'll do a couple of questions on top part. Okay, speed and velocity. Again, it's going to be two different quantities like distance and displacement. Okay, so what is speed? Speed is how fast an object is changing its location. Speed is always same distance speed is the distance divided by some time. So you take the distance the object travel and divide it by the time it's taken. Then the units of speed can be miles per hour, right? Like in our general life, but the SI unit is going to be meters per second. So there are so many units that you can use to measure the speeds. However, the SI unit will be meters per second. So it's meters divided by second. It will be m divided by s because those are the symbols for the unit. Also, you can use this version like maybe you have learned the factor like the powers of numbers. When you have s over here, the power over here is 1 on top. When you're taking it to the numerator, it will be minus 1 power. So it will meters per second. You can write this way as well. Or you can write meters divided by second. Without writing this division, you can write ms minus 1. So this is another way of writing it. Then the average speed is the total distance divided by the total time. So if you know the total distance it traveled, and if you know the total time it taken, then you take the distance divided by time. So for example, when you're driving, you say your speedometer reads, let's say 70 miles per hour. That means in 1 hour, if you continuously moving with that same speed, in 1 hour, you will travel 70 miles. That is what it means, 70 miles per hour. So in 1 hour, you are moving 70 miles. Remember, you need to go in that same constant speed to achieve that distance. Then rate, remember, like we learn about rate, that is the quantity divided by the time. So that is the rate of change of something, right? So there are other examples as well than velocities and speeds. That's gallons per minute, then pesos per dollar, points per game. That those are quantities, that rate of something, right? So rate of this. So average speed is the rate at which the distance is covered over a time. So you are, if you calculate if you measure the distance you travel, and if you measure it by the time it's taken, then you're calculating the average speed. So here, remember that other example. So let's say the distance it moves is 20 meters from A to B. I'm referring to the previous example. And let's say that object took 4 seconds to move that 20 meters. So then you take, what you do is you take the path length, the distance, divide by the time it's taken. So 20 meters divided by 4, which is 5 meters per second. And this is speed. Speed is a scalar quantity. It's not a vector. So the speed is not depend on the direction. Oh, I had that animation here. I'm referring to this motion. Remember, like from A to B, the distance, the path length is 20 meters. And let's say it's take 4 seconds. So the speed will be 20 divided by 4, and the units will be meters per second. So it's 5 meters per second. All right, let's try an example. I have a top hat question, but before that, let's practice doing it over here, and then we'll try another example. All right, so there's a runner who runs 200 meters to the east, then changes the direction and runs 300 meters to the west. If the entire trip takes 50 seconds, what is the average speed? It's asking average speed, right? So we need to know the path length. What is the distance this person ran? So total distance. So start from this position, let's say, and this runner runs 200 meters to the east and backward 300 meters to the west. So the total distance she ran is 200 plus 300, it's 500 meters. And then the time she took is 50 seconds. So it will be path length divided by the time, which is 500 meters divided by 50 seconds. So just division, 500 divided by 50. You can use a calculator. Even in the exam, you're allowed to use a calculator. So 500 divided by 50, which will be 10 meters per second, right? So average speed is 10 meters per second. Here, this runner runs to east and west, but we don't care about the direction because we are calculating the speed. Speed is a scalar quantity. It is not a vector, so direction really doesn't matter. All right, so what is the instantaneous speed? So we learn about average speed. What is instantaneous speed means? So instantaneous speed is the speed at that precise instant in time. So it is the rate at which the distance is being covered at a given instant in time. So at this second, what is the speed? You're not waiting for a longer time like 50 seconds or 1 hour. You just see the speed at this instant. So it is found by calculating the average speed over a short enough time that the speed does not change much. What's that mean? Yeah, again, it is kind of an average speed because we are looking at a 1 second, but 1 second means 60 milliseconds, right? So there's a little time change there. Even though you go for a millisecond, there are nanoseconds there. So it's hard to define what is this instantaneous time means, right? So basically what you do is for a very short amount of time, you measure what is the the distance it traveled, and then you calculate the speed. Okay, so in car speedometer, what does it measure? Does it measure average speed, instantaneous speed, or average velocity, or instantaneous velocity? You know the car speedometer, right? So in the speedometer, it's, what does it read? What do you think? You can come up with an answer. So is it measuring average speed or instantaneous speed? Velocity, we keep those out because velocity consider about the direction. In our speedometer, we don't see what is the direction is unless you use a compass somewhere. In most of the side mirrors or the back mirrors, we see the compasses, but not on the speedometer, right? So in the speedometer, does it measure average speed or instantaneous speed? If it is measuring average speed, we have to wait for a while to see the speed there, right? So basically, the speedometer measures the instantaneous speed. Okay. So here's an example of a speedometer. I don't know what type of car you have, but in many vehicles, we have the speedometer with two different number rows. So here we have black color numbers and a blue color numbers over here, but you can read the scale here. So black color represent miles per hour, but the blue color lines represent kilometers per hour. So if you visited to somewhere in Europe, then the vehicles reads kilometers per hour, not miles per hour. Even the signs on the highways, it reads kilometers per hour. So it's good to know how to convert this unit. But basically, in most vehicles, we see this both units, so miles per hour and kilometers per hour. So we don't need a calculator to convert the units, right? So you basically can read it from the speedometer. It's there. So for example, this one, it's somewhere in between 30 and 40. That's about 35, right? So it's 35 miles per hour. In kilometers per hour, it's a little lower than 60 kilometers per hour. So speedometers comes with two different scales. It's depend on where you live, but in most of the time, we can read both values with two different units. Okay, so highway patrols. So, you know, like we are afraid, we don't like them, right? So they're catching our high speed. So what are they measuring? They use a little device that they can send a sound wave, and then they detect the speed of our vehicle. Are they measuring average speed or instantaneous speed?
B.
B? Yeah, it should be, right? So they're measuring the instantaneous speed. But if you ever face that problem with the petrol people, they're just following us for a little while, like 5 minutes or 10 minutes, and then they see like whether we are really driving fast. In that cases, they are thinking about average speed, because most policemen are really nice to us, right? So they see like whether they are high speeding for an instantaneous time, or are they going to continue in this high speed. So most of the time they do that. But the devices that they have is measuring the instantaneous speed. So they measure the instantaneous speed, but as they're being nice, they wait for a little while to see whether they are following that high speed. Okay, what is velocity? So velocity is different from speed, because, you know, like we are going to define a scalar quantity and the vector quantity. So the velocity is a vector quantity of the speed. So it's kind of directed speed. So you're traveling in particular direction. So let's say I'm traveling with 45 miles per hour to the east. Then I'm talking about the velocity. It's not the speed, because I'm not saying just a number. I'm just directing another direction as well. So it's going to be a vector. So velocity is the rate of change of displacement. Remember, displacement is the vector quantity measuring the distances. So velocity means the rate of change of displacement. So here in this example, the path length is 20 meters, but the displacement is 12 meters. And to have this displacement, whatever this vehicle take 4 seconds. So if you want to calculate the displacement, what you do is you take the displacement, if you want to calculate the velocity, you take the displacement, divide by the time it take. So it's going to be 12 divided by 4. So it will be 3 meters per second. Now again, I need to define the direction. Now I'm using a different direction here, right? North of east. Why is that? Again, the direction, it's depend on how you define it. So it can be 20 degrees from the horizontal direction or from the positive direction. But you need to define your direction on the picture, or you need to write it down. Anyway, so the direction is required when you are writing the velocity. So velocity cannot be just 3 meters per second. It should be 3 meters per second to the east, 20 degrees from north of east, or 20 degrees from the east towards north. So something like that. There should be some indication of direction. Correct, okay? Not any direction, but the correct particular direction for this reference motion. So velocity is a vector quantity. Speed is a scalar quantity. So velocity involves direction of motion as well as how fast the object is going. Again, velocity is a vector quantity. Vectors have both magnitude and directions. So velocity has a magnitude. That part is the speed. So 20 meters per second, that's kind of speed, right? So 20 meters per second is the speed. And also it has a direction. So we say like, is it moving to the right? Or is it moving to the left? Is it moving to the east, west, 20 degrees from north? Or any type of direction should be indicated in the when you are defining the velocity of an object. So a change in velocity can be a change in object speeds or direction of motion. Now let's say I want to change the velocity. Then you can change the speed, which is that example 20 meters per second. If I want to change the speed, I change it to, let's say, 20 meters per second to 50 meters per second. So there's a change in the speed. At the same time, you can change the direction. So if you change the direction, then it gives a velocity as well. I think you didn't get it. So let's say you're moving with 20 meters per second to the east. And then in 4 seconds later, you are still moving with 20 meters per second. Let's say you're moving to the north direction now. So you change your direction, but you didn't change that quantity. So your speedometer still read 20 meters per second, but you change the direction. That will result in changing velocity. So basically, velocity can be changed either by changing the direction or by changing the magnitude. So basically, the speedometers doesn't indicate the direction. It's just indicate the instantaneous speed. But you can add the direction of motion, and then you can define the velocity by using the speedometer value. Okay, in this example, there's a car that's take a, let's say, a roundabout. So it's taking a curvy path. Is the car's velocity changing? I think there should be more information in this question. So let's say this car is traveling 10 miles per hour and when taking this bend. So it's taking a bend, a curvy path, but the speedometer reads 10 miles per hour. In that case, is the car's velocity changing? Now, speedometer is, oh, sorry, go ahead.
No, because it's still 10 miles per hour.
Okay, that is where the confusion come in. It's not changing its speed. 10 meters, 10 miles per hour. It's traveling in 10 miles per hour, but it's changing its direction. So when it's changed the direction, it's changed its velocity, but it is not changing the speed, but it does change the velocity because it's changing the direction. So maybe you have tried like, if you have a pet dog, you're taking the dog with a leash on it. So dog is running around you like a circular path. And let's say dog is running with the same speed. So speed is not changing, but the dog is changing its direction at every second, right? Because it's going in a circular path. In that case, the dog's velocity is changing, but the speed will be the same. Like in this example, like 10 miles per hour everywhere. That's the speedometer read, but the car is changing its direction. So velocity is changing. Okay, with this one, so there's a ball that hits on the wall and it's change its direction. Let's say it's follow the same velocity, the speed values. Okay, so here it hits the wall and change its direction and bounce back. Let's say with the same speed. So there's no change in the speed, but there's a change in velocity because it's changing its direction. In order to have a direction change, there should be a force applied to that. If there's a force in there, it will change the direction. Like in this one, there will be a force coming from the wall. Now in the vehicle, we need to give gas, right? So even though you are traveling with 10 miles per hour, when you are turning, you need to give gas to change the direction, right? So there should be a force applied to change the direction. even though you don't give gas, you will turn your steering wheel. So you're basically turning your vehicle tires by applying a force. So to change the velocity, you need to apply a force. That is where the Newton's laws comes in. We will go in that one later in detail. But for now, remember, in order to change the velocity, there should be a force applied in there. All right, so let's try this example. So the same runner runs 200 meters to the east, then change the direction and runs 300 meters to the west. If the entire trip takes 50 seconds, what is the average speed and what is the average velocity? 200 meters to the east, 300 meters to the west, and the trip takes 50 seconds. So average speed. So we take the total distance, divide by the time it's take. So it will be 10 meters per second. Are we doing the same thing? I know. Average speed. Now, what is the average velocity? I think I didn't put the average velocity. Anyway, let's talk about it. So this is the average speed, which is 10 meters per second. Now, if you want to calculate the velocity, what you do is you calculate the displacement. So basically, it's 300 minus 200 to the west, right? Divided by 50 seconds. So 100 divided by 50 seconds to the west. So direction is really matters when you're calculating the velocity. Okay, so let's calculate velocity. That means displacement divided by time. Here the displacement will be 100 meters to the west because this person runs 200 meters to the east and 300 meters to the west. So the displacement in this picture, it's from here to there, right? So it's only 100 meters to the west. That is the displacement. Then the time taken is 50 seconds. So it's 100 meters to the west divided by 50 seconds. So 100 divided by 50, that's 2, right? So it will be 2 meters per second to the west. So there should be an indication of direction and the number. I think let's try. Okay, so I think I have it here. I'm sorry, I didn't put it in the correct order. Okay, so in hold on, what is this one? A second here. Okay. Okay, we'll come back to that one again. Let's try a couple of questions on top hat and then try this. Okay, send your attendance code. I'm receiving your attendance. That means you can see the top hat on your screen, I guess. Okay, I'll keep it open.
Excuse me, I have a question. I was wondering, when are you going to upload like the next portion of the top hat attendance on the black canvas blackboard, whatever we used?
Yeah, I didn't calculate. I didn't include the top hat participation for midterm grades. I will do it soon.
Okay, thank you.
I know I have a lot of students who regularly attend the class, but there are students, like a whole bunch of students that come and they send emails saying a lot of reasons. So when I read the emails, I have to accommodate everybody. So it takes time. I'm sorry about not uploading the grades yet for
No, you're fine. I was just curious.
presentation. Yeah, I don't know. I'm still thinking, and I'm getting assistant from the department to see like how can I accommodate all these people.
Okay,
It's
thanks.
a really hard time, and it is. I don't know. Maybe I'll
I
do.
understand, but thank you.
Yeah, sure. It will coming up. It come up, but if you attend the classes, it won't. It will not going to affect your grade anyway.
Okay, thanks.
Yeah. All right. Okay. Let's try this question. Start presentation. Okay. So I'm going to stop counting the attendance because I see all of you send the attendance code already. Okay. So I'm finishing counting the attendance. Okay. Right. Does anyone need more time? All right. So I have 95 students in the Zoom, so I think I'm good. All right. So let's try this. Okay, so shall we check the answer? So it's a runner runs 500 meters to the east, then changes the direction and runs 300 meters to the west. If the entire trip takes 20 seconds, what is the distance the runner runs? So distance is not a scalar, not a vector quantity. So direction doesn't matter. Let's see. Yeah, so it should be 800 meters. It's asking the distance the runner runs. So it's like path length. So this particular runner runs 500 meters to the east and change the direction, runs 300 meters. So in total, the runner runs 800 meters, right? So it should be 800 meters. Answer is C. 200 meters to the east. Okay, you're getting a next question. I think you should be fine. Let's see. Those who answers D, let's see how you do in the next one. Why can't I move? Okay. Here you go. Here's the second problem. Now, the same person, 500 meters to the east and runs 300 meters to the west. The trip takes 20 seconds. What is the displacement of the runner? So displacement is a vector. Okay, so let's see your answers. Oh, I still have that variation. Okay. All right. So if the distance is 800 meters, the displacement can't be the same. Displacement means the shortest distance. Okay. So basically the direct distance. And there should be a direction involved in that. So this person runs 500 meters to the east and run 300 meters to the west. So there's a little gap there, right? So it's from the start position to the end position. That is what the displacement means. So That's 500 minus 300, that's 200 meters. And what's the direction? Because it's 500 meters is into the east, right? So there should be a 200-meter gap in there. So it's 200 meters to the east. I think as I have 20, 30, yeah, I have half here. So what I'm going to do is I will explain it a little bit. All right. So as it's given in the exam, the problem, there's a person who runs from one particular point. So let's say starting point is here, and he go from here to the west, right? So to the west, that's the west direction, and he goes 500 meters. 500 meters, right? And then at that point, so here's the start point. That's the starting point. Let me change the color. This is the starting point. Here, that's the starting point, and he go all the way to 500 meters to that side, and then he change his direction and come back to the east. Opposite of west is east, right? So he runs to the east, but this time he goes only 300 meters to this point, right? So he goes 300 meters to the west, to the east. Tell me, what was there? Is it east or west?
East.
500 meters to west and 300 meters to east?
I think isn't it 500 to
Yeah.
East. Yeah, this is west.
Yes.
That's west and this is east. Yeah, so in the beginning, he ran to east 500 meters, and then he turned and ran 300 meters to the west. Now look at this. There's a little gap over here, right? So that is the displacement. So here, this is going to be the displacement. From the start point to over here, the gap is going to be 200 meters. Here, it's going to be 200 meters. So displacement is 200 meters, but there should be a direction involved in there. So what is the direction? It should be to the east, right? Because that's how we define our direction. Because we said initially he ran to the west. This green color arrow, it's west, right? Sorry, it's east. We define that the green color arrow direction is east, and come back, that's the west. So there's a gap here that is 200 meters, and the direction is to the east. So answer should be 200 meters to the east in this problem. Okay. So that.
Why don't we divide by time for that question?
Yeah, because it's asking the velocity. So you get the displacement. And then divided by time. So here we know the displacement is 200 meters to east. And then you divide it by the time it taken. So how long it took? 20 seconds? Okay. Whatever the time it takes. So let's say it's take 22 seconds. So you divide by the time it take. That's how you calculate it. And the answer should include the direction in there.
Okay, and that's only for velocity?
For velocity, yes. So it's
Okay.
velocity. It's asking for velocity. Even for displacement, the direction should be in there because displacement is a vector. Velocity is a vector. So direction should be in there. But for distance, you don't need the direction. Now, in this example, what is the distance the runner runs? It's 500 to the east plus 300 to the west. So total distance the person runs is 800 meters. That is the distance. Now, if you want to calculate the speed, then you take the distance, which is 800, and then you divide by the time. I'm not using a number because I can't remember what I had in the question. Right? So you take the speed. If you want to calculate the speed, you take the distance divided by the time the person took to travel the whole distance.
Thank you.
All right, so let's try again another question. Now let's calculate the average speed. Okay, so the runner runs 500 meters to the east. I'm using the same example, but we are calculating 4 different things. And then changes the direction and runs 300 meters to the west. Now the entire trip takes 20 seconds. What is the average speed? Remember, the speed is distance divided by time. Okay, so let's see, because yeah, I think it's time is 10:30. I don't have my watch here. Okay, so let's look at your responses. Okay, good. So I got most of you in the correct place. So yes, so the average speed is 40 meters per second, because the total distance travel is 800 meters. Then you divide it by the time it takes, 20 seconds. So 800 divided by 20, which is 40 meters per second. Okay, let's try this. Now the same runner, what is the velocity of the runner? When you're calculating velocity, you need the displacement. So there's direction involved in that. And then you divide it by the time the person took. Do the calculation on a paper. Mental calculations doesn't help all the time unless you are very smart doing this. After you practice a little bit, you can do it. Like mental calculations are fine. Okay, let's see your answers. Okay. Okay, I catch you. Here, 10 meters per second. That's true. That's the velocity the magnitude. But you need to tell me what is the direction, because velocity is a vector. So this direction piece is really important. So answer is A. It's 10 meters per second to the east. So those who answered the answer C, you didn't care about the direction. You need to care about the direction because velocity is a vector. There's only 4 quantities, right? So let's say distance and speed go together. They are not vectors. They are just scalar quantities. So the distance and the speed. Then comes the displacement and the velocity. They are vectors. So you need to tell me the direction and the magnitude value. Okay. So it's not that hard. It's very simple. There's only 4 quantities that we introduced today. Right? So yeah, pay attention. I see like almost all of you got the correct number, but 20 of you got messed up with the direction. So direction should be included in there. Okay, I don't know how you got 15 meters per second. I think you got 300 divided by 20. No, we don't do that. We just want to calculate the difference and divide it by the time. 40 meters per second east? Not really. It is the yeah, velocity doesn't mean the direction and the speed. It's a totally different thing. So you need to calculate it differently. Give me 100%. Okay, that's a straightforward question. So please send me your answers really quickly. All right, so let's look at your responses. Okay, it's instantaneous speed. Yeah, we talked about it, right? So please review the slides. Okay, so what do you think? Average speed is calculated by how do you calculate the average speed? Okay, so let's look at your responses. Isn't it? It's amazing, like you're in various places, right? But I receive your responses really quickly. It doesn't take even a 1 minute for 100 of you to answer, and I see the answers from here. That's all electromagnetic waves. So when you're typing these digit codes converted into a electromagnetic wave, and that's get propagated, right? We don't have any physical connections. It's coming from the air, from internet services, right? So it is interesting. It's electromagnetic wave. If we can see the electromagnetic waves, think how crazy it's going to be. Like you can see millions of waves around us. So nature is interestingly designed. We only see only that 600 to that visible range, which is really good. I'm glad. All right, so let's see your correct answer. Yeah, so a correct answer is C. You take the distance traveled and divide it by the time it taken. Dividing the elapsed time. No, time divided by distance. No, you're taking the distance divided by time. Meters per second or miles per hour. So the numerator going to be the distance or the displacement, then divided by the time.